Now learning physics will be great fun with a physics teacher, a solution to all problems in physics.
The physics teacher.
A pendulum bob of mass m initially at rest is applied a constant horizontal force F is equal to mg. The maximum angular deflection of the string with vertical is, we have to choose that which option is the correct option. So this is the arrangement in which we have hanged a bob of mass m and we are applying a constant force F that is equal to mg in the horizontal direction. So here we have to find out that up to what maximum angle that bob can be deflected by the application of this much force. Now let us suppose that at any instant of time the position of this bob is, say, this. So this is the position of the bob, and let at that instant the angle is theta. Now if we observe carefully, this force that is constantly acting on the bob is mg, and also another force that is acting on it is the weight of the bob. It is acting in this direction. Now due to the application of this force and due to this force, presence of this force, this bob is displaced from this position. This is the initial position of the bob, say this is the final position of the bob. Now it has got displacement from its initial position to this final position, and in doing this, say it has moved through a height, say y, and it has moved through x along this horizontal or in the horizontal direction, and supposing the length of the string is L, so this upper part is L minus y. Now from this triangle, if you evaluate x and y, so we will get x equal to L sine theta and y is equal to L into 1 minus cos theta. Clear? Now what we have to find out? We have to find out the maximum angular deflection of the string with the vertical. Now in order to find this, we are using work energy principle, work energy principle or work energy theorem. Clear? Now what this theorem says that, this says that the sum of all the works by all the forces acting on the system is equal to change in kinetic energy. Clear? The sum of all the works is equal to change in kinetic energy. So here the initial speed is 0, so kinetic energy is 0 here, and at this final position again V is 0. V is 0 here again, means the final kinetic energy is also 0. So we have this change in kinetic energy equal to 0. Now look at this amount of work done in this situation. Now here there are two forces, one mg that is acting horizontally and one mg that is acting vertically, and what are the work done by these two forces are work done by the applied force plus work done by the gravitational force, and this is equal to 0. Now work done by the applied force is the applied force, clear, and the displacement in the direction of applied force, that is x, clear. Now work done by the gravitational force. Now if you observe carefully that mg, this gravitational force is acting downwards, clear, and this bob has climbed up to height y, means the force is acting opposite to the direction of the displacement of the bob. So the work done by the gravity in this situation is negative. So we will write mg into y. So from here you will get x equal to y. Clear? Now if you substitute the value of x and y, you will get L sine theta equal to L 1 minus cos theta. So from here you get sine theta equal to 1 minus cos theta. Now using trigonometric results for sine theta, we can write it as 2 sine theta by 2 into cos theta by 2. Clear? And we can write cos theta as 1 minus 2 sine square theta by 2. Clear? And finally we get from here sine theta by 2 equal to cos theta by 2, and this is only possible when theta by 2 is 45 degree, and from here you can write that theta is equal to 90 degree, and that is our desired result.